Let's talk about mobile web. What do I mean by this term? Not just browsing the internet using our mobile devices, but actually creating these applications using web technologies. So basically building any form of mobile apps using JavaScript. On my next slide, I'll introduce myself, but meanwhile, please give me a favor and think about your answer on one question. Just imagine, your project manager or your customer comes to you and says, your front-end MobileEra.Rocks, we need an app, mobile app. Which option would you go for? Searching for this answer is on our today's agenda. My name is Maxim Salnikov. I came to you from Norway, where I work for the company called FRONTEND-CON. I develop UIs for the future, or from the future. I'm a Google developer expert in Angular and web tech, and on my spare time I organize meetups in Oslo, where I live, dedicated to mobile development, web development, and its mix, which is PWA. Also, I'm the organizer of a MobileEra conference, and the next slide is about this event. Please follow me on Twitter. My handle is webmaxru, and I'll post the link to these slides right after the session. In just 2 weeks, MobileEra, and this is its website, MobileEra.Rocks, will come to Oslo for the second time. It's a conference about all the technologies we use to create mobile apps. Each framework I mentioned today will have a detailed session there. Travel to Norway is pretty affordable from Poland, so if you want to know more about mobile web, join us. Message me on Twitter, say that you are from FRONTEND-CON, you are attending this conference, and I'll give you a really nice discount. You remember the question, right? But first let's understand why it's ever raised. We all here use mobile phones. What about some global numbers? And they are pretty impressive. First, in 2014, the number of users on mobile devices bypassed the number of users on desktop. And it was quite a serious milestone. Next, starting from October 2016, just a year ago, mobile devices consume more traffic than desktops. It's also quite impressive. What about absolute numbers? This is a statistic on smartphone users. So we moved our focus from general mobile devices to the ones that we call smartphones. This is our target device for today. This year, it's well over 2 billion of users. And for you to better imagine this number, this is 60 populations of your large, lovely country. Plus, within most of enterprises, demand for mobile development is growing 5 times faster than internal development teams can actually deliver. Let's have a look at the evolution of web-based technologies for the mobile apps creation. Who remembers the name of this technology? Oh, exactly. This is a web protocol with its own WML language, but we skipped this era. It was the first try to expose something from web to mobile, and we jump to smartphones age when it became possible to render more or less real-life web apps in our mobile browsers. So this will be our first milestone. Then, thanks to Media Query, we could implement responsive web designs. Later we got nice hybrid mobile applications, we got even native ones. What do I mean by native on this front-end conference? Of course, the ones compiled to native from JavaScript, and even some unknown yet hero. Let's name some heroes from each milestone. jQuery Mobile, Bootstrap, which is mobile first starting from version 3. In hybrid, of course, the most well-known is Ionic. And you all heard the names of these native ones. But according to my color coding, there are two totally different ages of mobile web, separated approximately here. Before this, on the left-hand side, the hardware was low performant. JavaScript inside WebKit was painfully slow, and there was no possibility to use hardware APIs. Because of this and some other issues, Mark Zuckerberg in 2012 said this famous quote, and mobile web was not in the best shape before this year. I found really great visualization of the timeline showing this gap really clearly. So on this side we have very early versions of PhoneGap, just first tries, responsive web designs, and first attempts to implement some kind of mobile UI frameworks based on web technologies. Starting from here, mobile browsers got better. They started to support more HTML5 features and more device APIs, like geolocation, camera, accelerometer, and many others. And here is this gap. So we can say what's on the left-hand side is mobile web 1.0, and what we have now is mobile web 2.0, or mobile web 2nd edition, or mobile web done in a proper way. Let's return to the implementation. How can we use all these exciting possibilities? We have at least 4 really interesting approaches: Ionic, NativeScript, React Native, and this unknown hero. Who can suggest what will it be in my session? Right, EWA. It would be a big mistake for me to ignore this in my session, this really great opportunity to build mobile web experience. Of course, there are many more frameworks. Why do we take this? First, they are all open source, if it's applicable. And second, they are widely adopted by developers. Let's have a closer look to each of them via some experiences. Developer experience, something really important for us, right? User experience. We have to care about our customers, our users, plus we are all users ourselves. And just a bit of business experience. Before we dive deep into comparison, let me give a brief technical intro to each technology. Start from Ionic, classics of hybrid mobile applications. Basically, this is a website, HTML, JavaScript, CSS, some graphical assets running within native container. Its slogan, its code once running everywhere. And this is not just a marketing statement. We'll see how this unique feature works for Ionic. Let's list some features. For this and all next feature lists, I will emphasize only the ones that really distant one framework from each other. So main feature is really single code base for both native apps and web. This feature is actually a weak side of Ionic, right? But this is the core of the whole concept. We have an application that's running in what we call web view on native platforms. It's powered by Angular, but the next generations will be based on Stencil, a new framework from Ionic team. This is a compiler that generates web components, which will make Ionic framework agnostic. It uses Cordova to actually create the container and access native APIs. Cool. NativeScript, totally different approach. As a result, we have a truly native application without need for the web view. How it's possible? I'll give you all the details, but first, list of the features. It's recommended to use Angular framework, but this is not a requirement. So if for some reason you can go for this option, you can just use vanilla JavaScript. The app is shipped with JavaScript virtual machine, or even more specific, one of JavaScript virtual machines, because they are different for different platforms. Thanks to this feature, we have real direct access to native APIs. Here is a very rough explanation of how this magic works. Our JavaScript code interpreted and executed inside JavaScript virtual machine. We ship this machine together with our app. It's a V8 JavaScript engine for Android and WebKit JavaScript core for iOS and Windows phones. All calls to and from native APIs go through NativeScript runtime, which includes metadata. It's just a predefined set of all available API for each native platform. Type conversion, we have to convert our JavaScript types to native and back. And call dispatcher, which actually performs the call. This scheme guarantees that we can access any type and any function of the native APIs. Technically, on NativeScript side, on top, we work with custom JavaScript objects serving as a proxy to the native Android and iOS objects. But using this approach, you have to know the exact method for this or another platform. Luckily, NativeScript goes with platform-agnostic abstraction called NativeScript modules. It translates the code to a platform-specific code executed in runtime. Write code once. This is how it works. Move on. React Native. Result is really close to what we have with NativeScript. 100% truly native application, but the approach is totally different again. The slogan is learn once, write everywhere. Why? It doesn't promise us single code base for different platforms, and we'll check why. Features first. We have so-called bridge between our JavaScript code and native UI layer. The next slide is about it. It's inspired by React, but formally it's not a React.js, of course. Thanks to this architecture, we can do amazing things. We can have React native application as a part of native application. And for example, Facebook, Instagram, Airbnb, mobile devices work exactly this way. Also, we can include modules written in native language to our React Native application. So this is not just an access to native APIs, this is real native code that we can run. Let's have a quick look on how it works. We run our JavaScript code in a thread inside native app. To run it, we need a JavaScript interpreter. Another thread is responsible for application UI. It works directly with platform UI components and it calls platform specific APIs. Between these two threads, we have a synchronous bridge, which makes this communication possible. This flexible architecture makes it possible to run the application code not on the device or not inside the emulator, but inside our browser. This is really cool for debugging, and then it will communicate with a synchronous bridge via WebSocket. So this is really cool for development. After all, progressive web apps, just a quick heads up. They just adopt the best parts from these two different universes, mobile, native, and web. We are free to choose any tool, any framework, any superset of JavaScript to implement these applications. So basically we just use some modern browser APIs and follow some best practices to create our progressive web app. Cornerstone of EWA is the service worker API. Your application, outer world, and the service worker in between intercepting the requests and responding with its own responses. And of course, both application and service worker, they live inside your browser, but in totally different contexts. So what could we implement using these modern APIs exposed by service worker? We can get some functionality of our application available offline, like starting the application in general, storing some cached data, previously cached data, and even replaying requests user produced during offline mode. So after they got online, we can just replay all these requests. Really nice to propagate the data from the forms submitted during offline. Even online, we can optimize a lot of stuff by just using cached data. But the networking is not the only magic service worker can do. Also, it's responsible for receiving push events and actual displaying push notifications. And also, it helps us to organize communication between all our clients, which are open tabs in our context. And many more interesting things. This is a pretty extensive API. Good, now we know how everything works, right? Let's go back to the experience. Let's check what these frameworks expose for us developers. Installation and setting up is really smooth and nice for all these frameworks. So really nothing interesting to compare here. Each one has CLI, which will help you to scaffold the application, to emulate or preview in browser or device emulator, and to share and deploy. It's also applicable to PWA if you go for some framework. All the major frameworks include something in their CLIs related to PWA. So it could be a template to generate service worker during creation of new application, or just a flag which you use and get your service worker scaffolded for you. So the tooling is very good. What about coding experience? What do we use to write our applications? Ionic, pretty opinionated at the moment, at least. Angular plus TypeScript plus HTML. Why is it HTML? Because Ionic has its own markup, which is technically XML. However, you can use your standard HTML. You can easily recognize what's happening here. This is some kind of header plus single button in the center, right? And this is how it looks. The output will be different for different platforms. This is the nature of Ionic. It tries to mimic native UI of the corresponding platform, Android or iOS. Also recently they added Windows Phone platform. What about NativeScript? Angular is optional, but if you go for Angular, it makes sense to use TypeScript, right? Otherwise, you can just go for regular JavaScript. For the UI, we have to use XML with its own set of components. Why? Because there is no document object model anymore. We are not working with HTML now. Here again, the same. Action bar plus some simple button, and this is the result. Obviously, it differs from what we have seen in Ionic, because this is a real button in real iOS and real Android. React Native, inspired by React.js. So formally, we can say that we use React. This is why we go for ES6 and JS6. If you work with React.js, the syntax will be really, really familiar for you. Believe me or not, but React Native didn't have a simple button component until November 2016. Of course, there was some lower level ways to have this active area on the screen, but finally we are happy to get this native button component. This is the result. And by the way, the color we specify here has different meanings for different platforms. For Android, this is background color of the button, and for iOS is text color. You can ask me, in previous example, we had some action bar on the top. Where is it now? And this is a proper moment for me to tell more about learn once, write everywhere, instead of single code base idea. As you remember, the idea of NativeScript is to hide the differences of platforms behind its own API. So if we put action bar, we don't care is it Android or iOS, NativeScript will render something for us. But Android and iOS, actually, they are fundamentally different, and what we call action bar plays different roles in these two platforms. And React Native is embracing this difference instead of hiding it. So for iOS, we will use Navigator iOS component to implement this action bar. For Android, we go for toolbar Android. No worries, there is a really nice way to manage different components for different platforms, both on files level and on code level. So actually this is not a big issue. So this example demonstrates a fundamentally different approach between NativeScript and React Native. But you know, as always, real life is a bit more complex. For example, in this action bar, there are still some differences between iOS and Android, even for NativeScript. Why? Because this part of UI, as I mentioned, plays a really different role. For example, on iOS, the back button on this action bar is used explicitly for navigation. You can't even override this action. On Android, there is another limitation. You cannot put text on this button. It's only for icon. On the other hand, there are some cross-platform implementations of this action bar for React Native. For this specific case, I could recommend you to have a look at React Native navigation component, which actually does much more than just rendering this action bar. PWA, super simple. Any framework, if you go frameworkless, just use whatever could be transpiled to JavaScript and all good HTML. So it was about coding with the focus on UI. What about hardware? Because the whole point to create mobile application is not just to recreate a mobile version of our website, but to provide more interesting features connected to device hardware. Ionic. We go for Ionic Native. Nice set of plugins. Actually, these are Cordova plugins wrapped into a container which exposes promises or observables, everything that Angular loves. There are many plugins available. For example, if we go for camera, we just install this, and the code is quite simple. We import this component, we specify it as a dependency injection in our constructor, pure Angular approach, and we can use get picture method of this component which returns a promise. Super simple, super web-like code. Native. As I mentioned, thanks to its architecture, we have direct access to native APIs if we really need. Also, you can take almost any plugin from CocoaPods. This is a package manager for iOS, so you can use this one. And of course, it's equipped with hundreds of built-in and community-driven plugins. This list is pretty extensive. You can find everything that you can even imagine to use on your mobile phone. And let's have a look on the same feature, camera. So we just installed it, and the code is very similar because it's Angular again. So import and use some built-in methods. Get promise back. React Native. First, some hardware APIs are exposed as a part of the framework, for example, geolocation. Also, as I mentioned, if you are brave enough, you can go and write real native mobile code. Of course, you have to have some experience with iOS and Android then. Plus, a lot of community-driven components, really nice ones, again, for all possible use cases. This is the list of built-in APIs, and let's refer to some community-driven component. Very good list is on js.coach. For example, let's go for camera again. Use it. It's pretty much React.js-like syntax. JSX, again some method from camera object and returns promise. So awesome web technology in action at mobile device using hardware feature of mobile device. Progressive web apps. We are limited to use web APIs only because it's regular JavaScript app, right? So we don't have any Cordova plugins or native code, but actually it's not a big issue for many cases. The list of hardware APIs available in the browser is really large and it keeps growing. More than 250 APIs were added to Chrome only during the last year. You can check the possibilities of your current browser using this nice website called What Web Can Do Today, created by Adam Barr. By the way, he lives in Poland. I was really excited to meet him ago in another conference in Krakow. So for our camera example, we just go and use built-in get user media API. I believe now we have a good overview of what we can expect as developers. What can we give to our users using this or another option? Of course, the main point is performance in a wide sense, like smooth scrolling and transitions and fast networking. Disclaimer first, the key component of performance, of course, is the quality of our own code. So let's have an assumption that we write the best available code for this specific framework. There is no serious difference between native apps written in native technologies like Objective-C, Swift, Java, Kotlin, and the ones we create using web technologies and compile to native them. After all of them are truly native. Unfortunately, hybrid version of our application will never be as fast as the native. This is just an obvious limitation. More layers of abstraction, the slower is the slower speed, right? But I have to mention that Ionic team does a great job on optimizing everything what's possible to optimize. For example, there is a special plugin allowing you to switch web view type from the old one called UI web view to the new one called WK web view. It's not default yet due to some serious technical limitations, but you can try it as a plugin. Sooner or later, this will be the main default way Ionic renders the application. So we will get better FPS and lower memory pressure. Let's advocate a bit more for hybrid and web approach. Back to performance. Maybe once you got the performance which is fast enough for your users, maybe it's okay to stop here. I just want to say by this that hybrid apps works absolutely fine for many types of applications including business applications when you just don't need this 60 frames per second and heavy work with graphics. Also, these hybrid applications are super cool for super fast prototyping. And of course, browser vendors, in particular Chrome, work hard on improving JavaScript for mobile devices, so they become faster and faster. Our last chapter, some thoughts about business-related issues. And I have bad news for a native approach here. Almost half of the consumers goes to search engine instead of looking for an app in App Store. These two options, they basically can't offer anything to these users. Ionic goes smart way here. You remember I mentioned that it has this unique feature which is real single code base both for web and mobile platforms. So after some tuning and polishing, you can expose the pretty much same version of your application to wrap it to native container and ship it as a native app, plus to deploy it somewhere on web. For example, they introduced some optimized layout for desktop use, and also recently they added progressive web apps support to their web version. Let's continue with application stores and their issues. Again, bad numbers for native. App Store, in particular Google Play, is full of never used applications, and downloads go slower and slower if they go at all. The bottom line, it's very expensive to get new users for native mobile applications. In this sense, progressive web apps definitely win here. They are easy to find, just type the keyword in search engine and you are always there. They're easy to share, just send a link, and no reason to go to any app store, right? Easy to install, again, no need to go to any kind of store, and it's even hard to say that we have to perform some efforts to install the application, because in most cases it will show us a dialog, and we just have to pick read or not about installation. And easy to update. Just deploy a new version, and if your service worker written in a proper way, it will do the job for you on the next user's visit. So back to our question. We need a mobile application. Now you have something to say. You have some options, and most likely you already have some opinions on this. So let's go and create a nice mobile application. And please remember that the first action in a day for the half of smartphone users, which is more than 1 billion, is to grab their smartphone right in the morning. So please, let's do not confuse these people, and let's not make these people sad by our poor experience produced by mobile applications. Thank you very much. I'll be around in questions area after the session, so just catch me if you have any questions about Angular, PWA, mobile frameworks.
Yeah, and we have still 2 minutes more. If you have a question,
yes, please.
Maxim, please, don't be shy.
So I would like to ask a question, because PWA use service workers a lot. And how about Apple users?
This is a real good question. And I have great news for you. Just a couple of months ago, Apple stated that they changed the status of service worker support from under consideration to in development. No specific dates yet, but it was so great milestone for whole web community, and my tweet about it gathered just enormous number of likes and retweets, which shows that web developers are really inspired by this, and they were waiting for this statement from Apple for so long. So sooner or later we'll have it. And in addition, great news from Microsoft side. This fall, so really soon, they ship new Edge 16, if I remember correctly, with service worker. For now, it's hidden behind the flag, so for now it's for us, for developers, to get prepared. But next summer, 2018, it will be available for everyone. So, and I believe the interest to PWA will grow like crazy. So I see that it grows now, but it's just the beginning.
Okay, thank you.
You're welcome.
Have you ever think about security of service worker? Because it's executed on separate thread, it works even if browser not working, and for example, it is possible to mine some, not really Bitcoin, but some another coins in this thread.
You are right and not right at the same time. I explain. First, we can run service worker only for the sites that using HTTPS. So this is a security limitation. So the HTTP site will just not work as a progressive apps. Because yeah, you are absolutely right. Service worker is kind of man in the middle in this corresponding type of attack. So at least we cannot think about possible data like breaches in this channel because it's secure. About mining, service worker is event-driven work, so it wakes up only on some events from the browser. For example, fetch from our application, push notification from push messaging service, and it lives for not so long. So browser decides when it's time to kill the service worker. So there are some script execution time limitations. Different for different browsers. As I remember, for Chrome, for example, it's just 30 seconds or so. So it cannot run in background constantly. So no worries about this. The corresponding API, which is periodic background sync, is under consideration now, and it can produce something close that you just proposed.
Yeah, it can work and it has access to internet, so
yes,
a lot of use cases here.
You're right, but for this periodic sync, you have to give an explicit permission. So it will not start doing this job. Basically, this is like cron in your browser. So it will not start working without your explicit permission.
But from your side, developer, you can force, for example, by push notification. Wake up it and do something. It's pretty interesting, still open, as I see.
Yes, interesting possibility, but again, it will not run for so long. And there is one more layer of protection in case of push notifications. If you trigger push notification from this messaging service to your service worker, it's required to show some kind of notification to the user. So you cannot just like ignore this push that your service worker received. Even if you have not implemented displaying push notification itself, which is separate API, there are push API and notification API, the browser will show this pop-up with text, something like this website was updated in the background. So you cannot skip this action as a user, so you will see something.
Yeah, thanks for the talk.
You're welcome.
For the question and for the answer. Do we have a last question?
I have last question. So how many of you folks use progressive web apps, or maybe some experiments? Oh, nice. 1/3 of auditorium. Cool.
Okay.
Thank you.